Hello everyone, I hope everything is well at your end, and today we are going to discuss the problem generate parentheses. This is the problem number 22 on lead code, and this problem has been asked in Google interviews, and this is similar to the problem that we did last, which was valid parentheses, apart from the fact that in that we were checking whether a given string of parentheses is a valid string or not. Here we will be given the pair of parentheses, and it is just one type of bracket that we are going to receive, which is the round bracket, and we will be given a pair that is opening and closing, and we need to generate all combinations of well-formed parentheses. Now by well-formed, this means that the parentheses should be balanced. Now this can be done in a lot of ways. You can do it using stack, and you can do it using backtracking. Today the solution that we are going to discuss is through backtracking. Now if you want to understand how backtracking works and what happens in the backend, you can visit my backtracking video, and I have explained using this question only how backtracking works, and it generates all possible combinations of well-formed parentheses. But just to give you a quick refresher on that, backtracking involves making decision. There are certain choices, and you have to choose one of them based on some decision, and those decision basically should fall under a given constraint. Now this might be sounding a bit confusing, but I'll go and jump into the implementation, and along the way I'll explain it to you. But I'll still write down that we are going to solve this using backtracking, and there will be choices, plus there will be certain decisions that we have to make under some constraint. Now as you can see that we need to generate well-formed parentheses. So by well-formed, we can say that this is a well-formed parenthesis string, then this is a well-formed parenthesis string, then let's say we have something like this, and this is again a well-formed parenthesis string. But if we have a closing bracket first and an opening, something like this is not a well-formed string. So looking at this, we get an observation that closing bracket cannot come after an opening bracket, and also let me write down this observation: closing bracket cannot come before the opening. And the second observation that we are going to make is, let's take for example, we have something like this, and now we need to put either an opening bracket or a closing bracket. Now how do we decide which bracket to put? So if you count the brackets over here, we have one closing, two closing, and two opening. Now if you go ahead and put a closing one, this will never result into a valid parenthesis string. Why? Because we have put a closing string for which there is no opening bracket before it. So the second observation that we make is that when the number of closing brackets is equal to, or I mean there is no chance it will be greater than the opening bracket for a valid parenthesis string, but if it is equal, then we need to first put an opening bracket. So yeah, a valid string will be like this. So the observation, let me write it down. If I'll just write it in a very simple manner: closing brackets should be less than opening brackets when in the middle of constructing a valid string. Okay, so this is this. Now let's start the implementation. So we have these two observations, these are the constraints. Now the choices that we will have, the choices will be basically to whether to put an opening bracket or a closing bracket. and the decision we will make it based on the two observations that we have, the point number 1 and point number 2. These are our observations. So they are expecting us to return a list of string. So let's start with that. So this is my result, and this will be a new array list, and we will create one method that will generate all combinations. My keyboard is a bit sticky today. So generate all combinations, and yeah, we'll look into the parameters that we need to pass. So at the end we are going to return the result. We can put a sanity check over here, like if n is equal to 0, then we can return the empty array list. But yeah, we need not put it because they have given us a constraint saying that n will be greater than equal to 1 and less than equal to 8. So yeah, we can avoid this for this problem. Now let's construct the method generate all combinations, and in this we will be expecting the result list. Okay, now in the result list, so you can see that the result list is a list of strings. So it is expected that we will be pushing some kind of a string into it, some balanced string into it. So there has to be a base case, and we'll come to the base case later. So, and over here I need to push the string that is formed, the parentheses string that is formed. Let me name it current string. Now this tells us that we need one more variable, which is current string, and I forgot to define the type of this parameter. Okay, so we will come to the base condition as we progress in the problem. Now we also need to keep a check of how many opening brackets we have applied in the string and how many closing brackets we have applied in the string, because the moment we exhaust the total number given to us, that is the moment when we have found the string that we need to append into the result. So we need the number for that. So I'll be passing this number. Okay, for current string I can just pass in an empty string, and I'll be passing this number over here. Then this will be into this variable int max, and like I said, once we have exhausted the count of opening and closing brackets, we can say that we have reached a valid string, and we have made the right decisions, the right choices, and thus the opening and closing, since they are 0, so we can kind of say that if my open count equal to max and close count equal to max, basically we have added all the brackets that were allowed for us to add. So we need two more variables, which is int open and integer close. So here we are going to pass it as 0 0, because initially the empty string does not have any opening bracket or a closing bracket. So let's look at the next decisions that we have to make. So based on our observations, closing bracket cannot come before the opening bracket. So obviously we are going to have to put the opening bracket first, but there has to be a condition. So the opening bracket that we are putting, we can only put it when an opening bracket is available. So we are going to put a condition like open is less than max, and here we are going to put a condition like, we will call the function again actually, because and in this we will pass the result as it is. Now our string, which is the current string, we have to append an opening bracket, because we are applying an opening bracket. Since open is less than max, the count of opening brackets is less than max, and we will increase the open count by 1. Close count remains same because we haven't applied any close count. Max is same. Now let's come to the last decision or the last choice that we are going to do, which is applying a closing bracket. How do we decide to apply the closing bracket? So first of all, the first condition is met, that is the closing bracket cannot come before the opening, and the second condition, which is closing brackets should be less than opening brackets. So what we need to do is, when if close is less than open, so this satisfies the second condition, I'll just add this line, make close +1, open is untouched, and here we are closing the bracket. This is it for the program. Actually, recursion does the job of adding the brackets and finding out whether we have reached final string and appending it to the result. Let's look at how it runs. Okay, so we have encountered an error. Let's see what is the error. So it says private void. Okay, it is expecting something. I might have. Okay, let me see. It says it expects a comma. Wow. Wow. Okay, let me run a code. Okay. Semicolon. Small typos. Let me just cross check the program once again. If I'm missing anything. Yeah, it looks like it is correct now. Let me run the code. Yeah, so it works. Let me use the example test cases. Okay, let's submit the code. It works. So this is a very trivial backtracking question, and I will be explaining backtracking. I have explained backtracking actually in one of my videos. You can find it out. It should be somewhere here on the screen. Just go ahead and play that also. I have explained this question. I've drawn the recursion tree of this question, and I've explained how backtracking works. So this is it for this video. I hope you liked it, and please let me know in the comments if you want me to solve any problem. See you until then. Bye.